Hello, my name is Richard Weber, and today I'll be relaying some ideas about the hardware-software interface from the RTL team perspective. A large part of my career was spent as an architect and RTL designer, and I'd like to share a couple stories about things that had happened in my career with regard to the hardware-software interface. I was a principal engineer at a large company working on a set of ASICs. We were an experienced, well-funded team, and we had some new prototypes in the lab. First shipment of the product was waiting for us to finish in the lab. The software team was bringing up the device drivers. My job as part of the RTL team was to support the software team's efforts in the lab and hopefully make this go smoothly. Keep in mind that the sales and marketing teams were waiting for us to finish. Unfortunately, the prototype wasn't behaving as expected. There was some sort of issue. The management team basically handcuffed me to the lab, okay, figuratively, with a software engineer and a logic analyzer to figure out what was going on. This was a terrible time. It wasn't just hours and minutes going by, the calendar was flipping. And naturally, our managers were asking us how things were going continuously. I'm sure you've all been there, or you're going to be. So realistically, we were spending a lot of time, and time equals money and market share. It's certainly better to get products out sooner than later. So why was I imprisoned in the lab with the logic analyzer and the software engineer? We were desperately trying to figure out what was going on, and basically, why did my life suck? It all turned out to be a typo. So this was a surprise. We had homegrown tools, lots of scripts, thousands of lines of Perl to make sure this kind of thing doesn't happen. Our intention was to stop manual entry and certainly the typos that come from that. But our software team didn't use it. Thousands of lines of Perl script wasted. Software didn't use it, and worse, they didn't tell us that they were using it. Having a tool and not using it is the equivalent of not having a tool. What was the actual problem? The script paste output for the C header file didn't have the C structures that the software needed to develop their software driver. So they decided on their own to create their own C header file by hand. This ruined our idea of a single source and added a manual step to the entry development process. Homebrew automation didn't solve our problem. You'd think we'd learn. Now I'm going to tell another story about another project that I worked on as a principal engineer. In this case, a product was already shipping for a year to our customers. The team members had already been dispersed to other projects. But marketing wanted us to have a new feature that was deferred at first customer ship. So the software team was tasked with writing a new device driver, and they put a lot of resources on it and were working on it for a couple of months, and then they came back with the result that it couldn't be created. There was a problem with the way the hardware-software interface was laid out in the actual device, and this prevented a device driver from being developed. This problem was so bad it required a respin of the device. Certainly this is the first time this has happened to me in my career, and realistically, I was surprised by about 1 out of 7 ships actually being respun because of a problem with the hardware-software interface. Now clearly, this is time, money, and market share. This time it was really bad, much worse than the previous negative experience, because this time we had to reassemble the team from whatever projects they were currently working on. In other words, those projects were delayed now. We had to respin the device, and that took a good part of 6 months. and we had to spend the money on the respins. And then it even got worse. We had to take all those devices that were already in the field and retrofit them with the new chips that we just had developed. So this was a serious amount of time, a serious amount of money, and one could only imagine that some market share had slipped away while we were working on this. So we finally learned that there's certain things that have to be in place for the entire project to be successful. We've decided to use a single executable source for the address map. Well, what does that mean? Realistically, what it means is that one person types in what the hardware-software interface is supposed to be and how it behaves, and then everybody else gets the benefit from that single entry and gets the files and the outputs that they need to do their jobs, all from that single source with some sort of automation. Realistically, these automation tools have to work with a lot of formats. CSR spec, system RTL, spreadsheets of various forms, IP-XACT, and realistically, these have to be put together and they have to be verified that the design is correct. Then once the design is known to be correct, then you can generate C header files, files for RTL, files for verification, perhaps even some files for your technical marketing team. Automation makes early conversations between the hardware and software team possible. These conversations are important to avoid trouble later. Discuss which fields can be in the same register. Discuss how fields should behave for both software access and how they interact with the software. As our first issue indicated, having the right structures for the software team is important. It's very important to have those in the very beginning when you're entering the design for the hardware-software interface. Realistically, all the input formats have the capability of providing these structures. CSR spec has groups, system RTL, IP-XACT, and UVM all have register files. Use arrays. Arrays make the code smaller for the software team and for your verification team. CSR spec, system RTL, IP-XACT, UVM all support multi-dimensional arrays for register objects, for fields, for groups of registers, so use them. They make life better for everybody. Now, we've spent some time talking about industry standards, but will they save us? Let's go through some common standards that are used in the hardware-software interface. Accelera System RTL 2.0. Now, this is an older standard, and we see the customer base is moving off of that. Unfortunately, the layout and behavior capabilities of System RTL are limited compared to what our customers need to do. There's an interesting mixing of Perl and System RTL that makes it difficult to work with. And the number of properties is quite short compared to some of the other input formats. Another standard is IEEE 1685-2014. This is another Accelera standard that was moved up to IEEE. But realistically, this standard is really all about moving information about an IP from, let's say, a third-party provider or maybe an in-house IP team to the design team that's assembling a device. And it realistically only documents the interfaces. And for the hardware-software interface, there's only about enough information to generate a C header file. Another standard that's part of the Accelera family is IEEE 1800.2, 2017 UVM. This is another standard that Accelera has managed to move to the IEEE. This one is, however, totally focused on verification and really doesn't have any more information other than what you need for verification. Where standards fall short. There is no such thing as the everything standard. Each individual standard is missing something. And even worse, they're incompatible in subtle ways. And this is quite complex. Some of them are, you look at the documents for these standards and there's maybe even 1,000 pages there. And standards take a long time to develop, or they also take a long time to change. One of our jobs here at Semifore is understanding the standards and making them work with each other for for our customers so they can get their jobs done and get those chips out. We definitely want to recommend that you avoid the anti-standard. A lot of these standards have escapes to allow you to include information that's not standardized. Certain examples of these are user-defined properties, vendors extensions, and quirky registers. Now, the more you use these escapes and these standards, the further away you get from the actual standard itself, to the point where the files that you've created are unusable anywhere else other than your own environment, and sort of defeats the purpose of having a standard and taking advantage of industry support for that standard. What about scripts? Gosh, I used to write a lot of scripts myself, but the things you have to ask is, well, first of all, who writes them? And certainly, will these people be around for the long term for your project to be completed? Who maintains them? If these scripts are going to live more than one project, one could imagine you need a whole team of people to maintain the scripts. Where's the documentation? If I wanted to use an in-house script, where do I go to learn how to use it? What about the checking the quality of the inputs? Certainly, most scripts are minimum effort. In other words, as soon as the output looks right, it's a thumbs up, and that's as far as anybody works on the internal scripts. The thing that's missing is making sure that the input's right. It's one thing for the correct input to generate the correct output, but you also have to know that you have incorrect input, and you really don't want that garbage output. What about performance? A lot of these scripts are written in scripting languages that have severe penalties performance-wise compared to compiled languages. What about size? Over time, your designs are going to get larger and larger. Will the script-based solutions and the limitations of the script-based languages be able to carry you over to the larger designs? So be wary of homebrew automation. Once again, who's going to maintain it, who's going to make sure it's works with the size of the designs that you have, and does the homebrew solution actually make sure the design is correct? So we recommend you be open to commercial tools. Tools in the hardware-software interface have been available for well over a decade now. Many of them are industry proven and ready to go to solve your project. So for instance, Semifore provides the CSR Compiler. The CSR Compiler works with all the industry standards. In fact, our team members are deeply involved with the standards committees themselves and help move the standards forward. The CSR Compiler is a real compiler and will absolutely make sure that the inputs are correct and follow the standards for those input formats, and that the design that's being described is self-consistent and correct. The CSR Compiler can natively generate all sorts of different file outputs for your various team members, for the design verification, for RTL design, for software development, and even for technical publishing in case you need to publish your documents for your customers. So now we have an entire team that has a single source entry. They have automation. The automation makes sure their design is correct and generates the outputs that each one of the team members wants to see, and a productive tape out. Thank you very much.